Logged into the AWS console, and I'm logged in with my administrative account. Okay, so I'm going to go into DynamoDB, and as I mentioned, I cleared out DynamoDB, so there is no data in this database. I'm going to create a new table, and when I create a table, so I'm just going to call it baseball stats because that's what the example uses, and it's going to ask for a partition key. And here's the way DynamoDB works, is this partition key is going to be important because what ends up happening is it gets hashed, and the hashing algorithm indicates where it gets stored physically on their storage system, whatever storage system they're using. They don't disclose it, but that hash determines where it physically gets located on their storage system. So when I add a primary key, it's a hashed primary key that indicates where it's stored, and what it does, so the real key factor with DynamoDB is it's got really fast retrieval. So if I tell you a lookup based on a primary key, it knows exactly where that data is stored. It's not stored randomly, it's stored in a specific location based on that primary key value. Okay, so I could say anything, but since this is a baseball application, I might want to store my primary key as team ID. And I'll give you an example of why I might want to use team ID. These primary keys, these partition keys, they'll call them hot keys versus non-hot keys. And the idea with these keys is you should have your lookups. So when I'm going to start using this data and I want to start looking up my data, I want it equally distributed amongst all of my different primary keys. So in MLB, there's 30 baseball teams. So I have 30 different team IDs, and my prediction is that if I keep track of all these baseball stats, they'll be pretty evenly distributed amongst the teams. Is that fair? Alternatively, like if I used like a date, so I said I'm going to store all of my baseball data and game data based on a date. The idea would be that yes, it would be evenly distributed. Each date would have the same amount of data, but once a date goes into the past, I'd never look at that data again. Right? I might want to look at current data, but how many times am I going to look up data from 10 years ago? I know some people do, but the idea is that it'll get stale. So that partition key is a really important key. It's how I'm going to distribute my data for both storage and then lookups, and I want it to be evenly distributed based on the primary key. So that key choice is more important than what we'd usually indicate with a relational database. With a relational database, we don't necessarily care. With a NoSQL database, I do care. Okay, so I want to kind of predictively choose that primary key. I can add a sort key. So a sort key is like a secondary key, and what it'll do is it actually creates a composite primary key. So in our case, team ID is not going to be enough to make it unique. Like, so I'm going to have records for the Brewers, and then I'm going to have records for, you know, April 1st, April 2nd, April 3rd, April 4th. They're all going to be tied to the Brewers. So I need a secondary key to identify unique records. So a team ID is not enough. I'm going to have additional data. All I'm going to do is just call it SK for now, so for sort key. And we're going to end up deleting this anyway. I just want to be able to get into the record or into the database. Okay, once we create this, okay, once I create it, I have this overview. We'll get into streams. Streams is essentially a transaction log, but I'm going to skip it for today. I get table details, and this is a provisioned database. And what that means is that I have a fixed amount of storage. So the default is 20 gigs of storage is free in DynamoDB. You're storing text, so 20 gigs of text is a ton. So you're not going to pay for storage, you pay for read and write units. Okay, and the way this works is your one read unit is 4K of data. Write is 1K of data. So everything I write is 1K of data, everything I read is 4K of data. That's one read unit, one write unit. And that's what I'm getting billed on, is how much I read and how much I write. Okay. My metrics will show how often this has been used. Capacity. So you'll see that it's provisioned and it shows me an estimated cost because I'm not on the free tier for my read and write capacity. You might see something different. I can change this. So if I change it to 20 and 20, now I'm up to $12 a month for this database. Okay. On demand, what that does is it'll allow me to scale my database size infinitely. So 20 gigs is free, but if I go over that, what's going to end up happening is I'm going to start getting 404 errors trying to access my database if I hit that 20 gig limit. So what I can do is I can say I want to go to on-demand storage, and my storage size will grow and grow and grow, but then I'm going to pay for it. Okay, so by leaving this provisioned, I know that I'm locked into that free tier. It's safer, right? Indexes we're going to avoid for right now. Global tables is kind of interesting. What will happen is DynamoDB will automatically replicate your database across different regions. So right now I'm in US East 1. But if I want to replicate this to China and I want to replicate it to some other country because my application's running in Europe and it's financial data, my data has to be stored in Europe. So I can create global tables. So I can add a region. Okay, and global regions are actually pretty expensive for that replication process, but I can do it, right? I mean, if I'm running a database in Europe because I'm a financial institution, chances are I'm paying for that database too. So yes, they're expensive, but it's cheaper than the alternative. Okay, so I skipped over items. Let's go back to items. Okay, so I have my table. My table is representing my entire application. I'm going to create a new item. Okay, so my team ID might be Milwaukee Brewers. Okay, and my sort key might be team info. And then I can add additional stuff about this team. So I can append a string, the mascot, Brewers. The location will be Milwaukee. The stadium capacity will be 44,000. I might want to store the owner. I might want to store, what ownership percentage. I can store whatever I want. Okay, and that can be different than another record. Okay, so if I create another record, my team ID might be the Chicago Cubs. And again, I'm storing team info. And then maybe that's all I want to store. Maybe I don't have the details about it. Okay, and this is a dumb example because I can get the information for the Cubs if I want to, but I can store whatever I want. I could also store player info. So the team ID might be the Milwaukee Brewers, and then my sort key will be player info. And then I want to know the first name and the last name. Okay, so see how I have different data depending on the record that I'm dealing with? So when I do a lookup, I really want to know, am I looking at a team or am I looking at a player? And I'm going to determine that based on the sort key. So with this table, the only thing I have to supply is the primary key, so the team ID, and then the sort key, saying what type of data am I dealing with? Am I dealing with a player? Am I dealing with a team? Or am I dealing with a game? Okay, and this is going to store all of my application data. Okay, so we could create a bunch of baseball data, and I think all of you would get fairly bored, right? Like well, unless you're into baseball. Yeah. Yep. Yes. Yep. Yep. Okay, so I'm going to head back over to DynamoDB, and I just wanted to show you kind of how easy it was to create a table and to create the primary key and the sort key. I want to create the same table but with some actual data inside of it. Okay, so in order to do that, I'm just going to delete this table, and I'm going to start from scratch. Okay, eventually it'll get deleted here. Okay, so now there's no tables, right? So if I go back to the dashboard, it says, hey, do you want to create a table? Because there are no tables. And what I want to do is I want to create that baseball stats table with actual data available to me. Okay, so I'm going to go ahead and open up my terminal. So a terminal is the Unix, Linux version of a command prompt. And you can see that I have that tool, that AWS tool. So here it is. And what I want to do is I want to load these files that I have, these exercise files that I posted on Blackboard for you, the games.json, players.json, teams.json. Those files, they're on Blackboard. Okay, so they're on the link to that course description, that link out to Linda. There's a zip file that includes those 3 files. What I want to do is I want to take those 3 files to seed my database table with data. So if I look in there, there's game data, there's player data, there's team data. Okay, so I want to seed that data. The way I'm going to do that is I'm going to use the command AWS DynamoDB, and I'll post these commands, so don't worry too much. But then there's a command called batch write item. Okay, and what this is really saying is go to the AWS application. I want to deal with the DynamoDB service. And then within that DynamoDB service, I want to batch write a file to a database. Okay? The file that I want to write is going to be specified by this request items parameter. And then I have to specify a file path. So I have to say where the file is. So for me, I know that the file is in the desktop under exercise files. Let's make this easier. Sorry. I'm going to print my working directory. So right now I'm in my profile directory on my Mac. I want to go to my desktop and I want to go into those exercise files. So I want to be in this directory. That's what I want my working directory to be. So I'm going to change my working directory over to this 202. And all I did is I dragged that folder onto my terminal. So it gave me the full path, so I can print my working directory, and you can see the working directory is on my desktop. So I'm in that exercise file directory. So now I can run that command really easy. I can say AWS DynamoDB batch write item. And then I have to specify my request items. I have to type it right. And then I'm going to specify my file. Okay, the file path is in my current directory, my current working directory. So I can just give it the name of the file, teams.json. And it tells me it wasn't found. If I hit the up arrow, it'll run the same command. So I don't think it'll automatically search in the current directory unless I tell it to search in the current directory. So this is what this / is telling it, saying from the current directory, find teams.json. Requested resource not found. My guess is if I look at this file, it's looking for that database table to exist, and I deleted the whole table instead of just clearing out the items. So I'm going to create a table called baseball stats. And I'm going to use team ID and SK as the sort key. Okay, so the table's getting created, then I should be able to come back over to the command. And I'm just waiting for that table to get created before I issue that command. Okay, so now it's created. Now I can come over to my terminal and issue the same command. Batch write item. So I screwed it up. So I did team ID. So I did uppercase I and lowercase d. It's case sensitive. So one more try here. I'm going to delete the table and recreate it because I can't change the primary key. Okay, so the table name I want is baseball stats, and then I want team ID. Okay, so now I should be able to create baseball stats with the team ID. I'm going to add the sort key of SK, and I'm going to create the table. Okay, once this is done, now I'm pretty confident that my command is going to execute and I'm going to have some teams. Feels like you're waiting forever when you actually want it to populate. Okay, so the command that I eventually want to run is the same command. I don't think the command is wrong. Okay, so now it's finally active. Now I'm going to run that command, and you'll notice that I get unprocessed items equal to an empty object, meaning everything was successful. And I can verify that, so if I go to baseball stats and I look at the items, so you'll notice I have some team info. That's from us loading that JSON file. Okay, so I have team info and then I have player info. So I want to go to players. I want to do the same thing. I want to import all the players. And then lastly, I want to import all the games. Okay, and now if I refresh the items, you can see that there's 23 items. So there's game info, there's some player info, and then there's some team info. Okay, and this is my baseball data. If I want, I can take a look at Mike Trout. So all it has is, here's his name, here's his position, his sort key, and his team ID. Okay. Life's good. So now we have some data. I want to show you how we can actually look at this data. So programmatically we want to look at it, but no SQL databases, the name would imply that we do not have SQL access, right? So if I go back over to a command prompt, if I want to access that database, I can do a scan or I can do a query. Those are the two things I can do with the table. So a scan, what it does is it looks at every record in the database. A query looks at a specific record set, and then we can really, like, not using SQL but using parameters, we can say, like, I want to query the database and I'm looking for items that have this primary key and this sort key. So it can filter it down, so I'm not reading every record in the database, I'm just reading a particular set, so I'm not getting billed for every record. Okay, so I'll show you the scan today, and then this is kind of where I want to wrap up. So I want you all to get to this point where we have a database created with some seeded data. And then what I want to do on Thursday is I actually want to query that data and write some, not SQL statements, but I want to write some queries. Okay, so I'll kind of show you the start of that today with a scan. So I can do an AWS DynamoDB. It's kind of a hard word to spell. And I want to scan my table name called baseball stats. Okay, and you'll see that I scanned 23 items. And it has all of my data. So it tells me there's 23 items, here's the items. And then down at the bottom, it shows you what the consumed capacity is, essentially what I'm getting billed for. I didn't ask for the consumed capacity. So it's not going to give it to me. It doesn't show me what I'm actually getting billed for that query or for that scan. So if I want to do that, so let me clear the screen. So I want to do this scan with a table name of baseball stats, but I do want to know what the consumed capacity is. So I want to return the consumed capacity as the total consumed capacity. It's a parameter. I'm asking for the total. Like, how much is this going to cost me to scan this entire table? And you'll see that it uses 1/2 of a read unit. So it's not 4K of data. So I'm getting billed for 1/2 of a read unit when I do that scan. Okay. Here's another thing that's going to come into play when we're dealing with DynamoDB. The way DynamoDB works by default is it's replicated across 3 regions for free. So your database is automatically replicated. When I do a read, what happens is during that replication process, my data may not be consistent across the 3 regions, but it's eventually going to be consistent. So if I write data, then it takes up to 15 minutes to replicate across those 3 regions is kind of what the documentation will tell you. So the default mode of reading from DynamoDB is that it's eventually going to be consistent. I'm reading eventually consistent data. Okay? That's what I'm getting billed for, is eventually consistent data. And for the most part, it works fine. Okay, unless it was just updated and I'm hitting a site that is one of the replication sites. If I want a consistent read, meaning I want the data to be consistent, I pay double the price. Okay, so you'll see I used half a capacity unit for the first read. If I do that same thing, but now instead I say I want to do a consistent read, so I'm doing a scan, and then I'm asking for the total, but I'm going to force a consistent read. I need the data to be accurate. Why am I not getting? Because I didn't spell it right. So you'll notice the capacity units doubled. My read capacity units. So it was half a read unit, but now I'm asking for a consistent read. I'm going to get billed twice as much. If I put that into a transaction, right? So we can have transactions where I can roll back and recover if something goes wrong. So if I put that into a transaction, it costs me double again. So if I want a consistent read within a transaction, it's going to cost me 4 times as much as just an eventually consistent read. Okay, and maybe I'm fine paying for that. Maybe I'm an insurance company and my data needs to be accurate. Versus I'm a hobbyist playing around with baseball stats and I don't care. If you get the wrong data, it's your problem, right? So that's how I'm getting billed. I'm doing a scan. A scan's always going to scan every record in the database to see what we're looking for. I can filter based on a scan, but I'm still scanning the entire table and then filtering. So it's still going to cost me the same amount of read units. I'm still scanning the 23 records. So whenever I do a scan, I'm talking about scanning the entire table. When I do a query, then I'm talking about I can get really specific about the data that I want to read. I want to read only the data that has this primary key and this sort key. So scans is always the entire table. Query is I can query based on a specific primary key and a specific sort key. So then I'm only reading the data that I care about. So it's always better to query than to scan. Okay, so on Thursday, what I want to do is I want to start getting into writing these queries. Like, what's the format of it? And the format starts to get a little messy. So you'll notice we're dealing with JSON, so we'll cover JSON a little bit on Thursday as well. So what's the structure of JSON? Like, how am I formatting JSON? What are the rules with JSON? And the reason we're going to do that is because when we start to query these database tables, our parameters are going to be JSON parameters. So you're going to need to know a little bit about JSON. And the reality is you're going to need to know a little bit about JSON in a lot of different places. So if this is the first time you're seeing it, it's fine. You'll see it again and again, and then you'll kind of know that it's not that bad. Okay? So I'm going to stop here for today. For Thursday, try to get your DynamoDB created, create your command line interface with your credentials, and upload that data. So seed the data. I'll put the commands that I use today out on Blackboard in that same section. So the commands that I use to seed the data. The only thing that you have to worry about that is your file path. So your file path will definitely be different than my file path unless you navigate to that working directory. So unless you navigate to where the files are located as your working directory, your path to the file is going to be different than what my path to the file was. But I'll post those commands out on Blackboard.